A blissful evening to you. I welcome you to class this evening. So this evening we are going to be talking about approximations. Approximations, and this is a topic that cuts across GSS 1 and GSS 2, even up to your GS 3. You will still need it. So we want to talk about approximations. So as a student, you must have been wondering why somebody who scored 44 and somebody who scored 49 in a promotional exam, why the cases of these two students are different. Why somebody who scored 44 maybe in a mathematics exam has been asked to repeat. Why somebody who scored 49 in a mathematics exam has been asked to get promoted to the next class. You must have been asking yourself about that. Okay, the reason is not far-fetched. If you look at 44, the person that got 44, his mark was approximated to 40 because the 4 here, when you use it for approximation, which we are still going to see much later, it only had 0 to this, and this one will vanish to 0. So 4 plus 0 gave us 4, and we have 0. As this 4 at the back is not up to 5, any number not up to 5, when you use them for approximation, they only had 0. They do not change the number. So the person who got 44 has his own score to be approximated to 40, while the person who scored 49, because 9 is in the category of numbers above 5, when you use 9 for approximation, it will add 1, and this turns to 0. So 4 plus 1, that will be 5, and we have 0. That's why somebody who got 44 was asked to repeat because he got 40, and 40 is not a pass mark, while somebody who got 49 was asked to be promoted as a result of approximation. And when you do the approximation, it leads to 50. Okay, so now let's go in depth further. So let's talk about approximation of numbers. Approximation of numbers. What are the key ingredients we need when we are approximating numbers? When we are carrying out approximation, okay, there is a span of numbers from 0, 1, 2, 3, 4, and we also have the second category of 5, 6, 7, 8, 9. Is that okay? When these numbers are used for approximation, that means when they are at the back of the number that you want to approximate, they will only add 0. They will only add 0 to the previous number. They round it to 0. Why when these numbers 5, 6, 7, 8, 9, when you use them for approximation, that means when they are at the back of a number you want to approximate, they will round the number up. They will add 1. They will round the number up. They will round the number up. And they usually had all of this category usually had 1. They will add 1 to the preceding number in their front. They will add 1. So let's move in depth. Let us see approximation of numbers. So I'm going to target approximation of tens, 100, approximation of tens, 100, 1,000, let's say tens of thousand. We are going to see all of this. So when they ask us to approximate them, how do we go about them? Okay. Before now, I want to believe that you have been taught place values, so you will know your place values very well. Okay, so let us say example 1. Let's us say you were asked to approximate 2, 4, 5, 8, 2, 3, 9, 2. And the question reads nearest tens, nearest 100, The next one reads nearest thousand. So how do we go about them? Okay, so look at the number 2458239. We are asked to approximate to the nearest tens. Okay, let's change the color of our pen to make it look colorful. Okay, so if you want to answer question A now, if you want to answer question A now, 2458239. So then the first one is nearest 10. So you have to locate which number is your tens number. So using the principle of our place value, the first value from the bar is our unit, followed by our tens. So this is where we want to work on. This is where we want to work on. So what is the number at the back of our 3? That's 9. And if you look at 9, I've explained previously that there are two categories of numbers you can use for approximation. When the number is either 5, 6, 7, 8, 9, when you use them for approximation, they add 1 to the preceding number. Why when you use 0, 1, 2, 3, 4 for approximation, they only had 0. So since we are equipped with that, now let us see how this goes. So 9 on top of 3, you will equally tell me that it is 1, Abby. Then so when you approximate that, then this one vanishes to 0. So this is the symbol for approximation, not an exact equal to, something like a curly, something up. That is not exactly the same answer, but approximately. So to answer question here, that will be approximately 24582. 9 on top of 3, that's 1. 3 plus 1, that's 4, 0. And this is your answer to the nearest tens. Okay, if we understand that, let us answer question B. What does question B says? Question B says to the nearest 100. Still same number, 2458239 to the nearest 100. So using your principle of place value, this is our units, this is our tens, this is our 100. So I'm working on this. The number at the back of my 100 is 3. So 3 on top of 2 is in the first category of numbers that can only add 0. So this will be 0. Then every other thing at the back of that 2 will vanish to 0. So your answer to the nearest 100 is approximately 2458. 2 plus 0, that's still 2. Then 2 zeros at the back. So this is the value for nearest 100. So let us move on to nearest 1,000. Let's move on to nearest 1,000. So still the same value, 2458239 nearest 1,000. So I'll locate my this is my units, this is my tens, this is my 100, and this is my 1,000. So I'm working on 1,000. The number at the back of my 1,000 is 2. So 2 on top of it is in the first category of numbers that can only be had 0. So this will have 0. It will have 0 on top of it. And every other thing at the back will vanish to 0. So when I'm to write my final answer, I'm going to have approximately 245. 8 plus 0 still remains 8. 8000. So that is that about that. And another thing I also like to, let us see another example. Another example. So they can ask you to do tens of thousands. Just put your place value and you do it accordingly.